Hi, my name is Emma Comstock-Reed. I am an 8th grade math teacher, and today I want to talk about how to use base 10 as a foundation for understanding rational and irrational numbers. So one thing you might notice when you look at this week's lessons is that the lessons on rational numbers come back to this idea of subdividing. You can see we have this visual that's the intro for day 27 that uses the bar model to encourage students to think about having, and then having again, and then having again. Then students place on a number line to discover like what happens to our decimal places the more we have 1/10. And they notice this relationship between subdividing the decimal and the number of digits that we require being more. So something that I think is really missing here for many students is a strong understanding of base 10. And the reason that we need to add decimal places being that we are taking our ones and we're subdividing it into tenths. And then we're taking our tenths and we're subdividing that into hundredths. And that idea can be modeled by base 10 blocks in the same way that we could model whole number division. So you may not be going in super depth with your students about the connection between rational and irrational numbers and our base system. However, it comes up in so many aspects of this that I do think it is worth it to consider how we are representing division in base 10 with students, because a lot of this understanding relies on that foundation. You'll notice that in the next lesson, students are asked to use long division to find the value of a third. And then in the lesson after that, day 29, students are looking at an example of long division that's been started for them, and they're noticing a repeated pattern in 3/7. So even though the base 10 system and long division are not explicitly introduced in this unit, these are things that students would ideally come in having a strong understanding of. These are still gaps that are certainly going to arrive for us when we're talking with rational and irrational numbers, which are complex enough on their own. So if we're going to expect that students are going to be able to be with us in these conversations about repeating and terminating decimals, rational and irrational numbers, we need to also make sure that we shore up the foundation about place value, about base 10, and about long division so that they're ready to attack this new content. So this is an app from the Math Learning Center, and I'll enlarge this website for you. And the thing I wanted to highlight here is that you can use base 10 blocks to model long division of whole numbers, but you can also assign the value of tenths, hundredths, thousandths to the same manipulative so that students can also see how we are subdividing a whole number into, tenths, hundredths, thousands, etc., in order to do that same process that we're doing with whole number long division. So I'm going to use this manipulative to model division of whole numbers and then a division that results in a terminating decimal. And I'm not going to go a whole lot into depth about how to use this manipulative, but I do want to point out this little I in the bottom right corner. If you go to this website and you're having any trouble navigating, you can always look at this info section and you'll see the how to and the about sections so that you have an idea of how to use the manipulative as well. So let's start by doing, and I suggest you do this with students as well, long division that students will know the answer to, so that they have the capacity to just focus on the process. So we're just going to do a 2-digit number divided by a 1-digit number. So we have 52 divided by 4. And the goal of showing students this is to make a connection between long division and the steps and what we're really doing with each place value. So we're saying we're splitting this into 4 groups. I'm going to make my 4 groups down here. And then we're going to represent this number, 52, using our representation. So we're going to take 5 10s and 2 1s. And we're going to say first, how can we split up our tens place? How many times does 4 go into 5? And we realize, right, that I can take 1 10 and put it in each group with a 10 left over. And the way we represent it for long division is for me to write 1, because I have 1 in each group. And then when I do this step where I multiply by the 4 and I subtract, what I'm actually doing is I'm saying, as I subtract, what do I have left? And then when I bring this down, I'm saying, okay, well, I have 12 1s left. And in order for me to split this up, what I need to do is split this from 10s into 1s. So I'm going to press this button here that splits up my 10 into 10 1s. And now I'll be able to drag them away. So now I'm saying, okay, well, how can I divide up my 1s? How many times does 4 go into 12? So I realize 4 goes into 12 3 times. And that means in each group I have 3 1s in addition to my 1 10. And I'm just going to add that here. So that's how to model long division with base 10 blocks. Now let's try an example where our answer will be a terminating decimal. So we're going to use the same shapes that we used before, but we're going to change what each part represents. So we're going to call the square a whole, the vertical bar a tenth, since it's a tenth of a whole, and we're going to call the small square a hundredth, since it's a tenth of a tenth. So we'll represent it in terms of long division. When we're thinking about 1/4, we are taking 1 and we are dividing it into 4 pieces. So we have 4 groups just like in the previous example, and we're starting with 1 whole. So when we ask ourselves, does 4 go into 1 evenly? It does not. I only have 1 1 here, so we have the 0. And we're placing the decimal place to show when we go out of the ones place and we split this into 10 tenths, we are moving into the tenths place. So when I say 0 times 4, 0, and I subtract here, this is where I said, okay, it doesn't go in. And now I'm making my 1 into 10 tenths. And I'm doing it so that I can divide those 10 tenths into groups of 4 as best I can. So I'm going to start equal sharing my tenths and see what I end up with. And the way that's going to show up in the long division is by asking ourselves, how many times does 4 go into 10? It goes in twice, which means I have 2 tenths in each group. And I'm going to represent that by writing a 2 in the tenths place. And now we go through the same process. I'm making 8 tenths total, which leaves me with 2 tenths left over. I took that 0 from there. Okay. And so now I need to, when I add this 0, what I'm doing is I'm changing my 2 tenths into 20 hundredths. And that allows me to ask myself, how can I evenly distribute my 20 hundredths into 4 groups? And that's going to leave me with 5 hundredths in each group. And I'll represent that now. So this is my suggestion for how to reinforce place value and long division with students as you lead into working with rational and irrational numbers, terminating and non-terminating decimals. I suggest this either as an intervention for students who you know maybe don't have as strong of a foundation in this beforehand, or if you feel your class out and you feel like they really need some reinforcement with long division before you start into the rational and irrational number lessons, this might be just a good model to show everyone so that students know how to use it as needed going forward. I hope this was helpful, and have a beautiful day.